class is being recorded, and we're just going to go ahead now and get to the content that you came here to hear. So I'm going to throw it over to Sy. So go ahead, Sy.
Thanks, Beth. Thank you very much. Thanks, folks. As Beth said, this is a small crowd, so yeah, Beth, as you mentioned, by all means, let them open up the microphones if they want to talk to us. Some of them I saw the list. Some of you guys I know, welcome back. Some of you guys I don't know, welcome to this presentation. I'm speaking to you from Cleveland, Ohio, whereas it's a little cloudy. It's not dreary, but it's a little cloudy here. And as Beth said, I'm the Director of Engineering, been with Southwire for about 17 years now. Actually, this month will be 17 years. Throughout my career, my career spans about 30-some years in the power distribution arena. I've started at a utility right out of college with my EE, started at a utility, Cleveland Electric Illuminating, and did a bunch of stuff with the utility. Got into the wire and cable business about 25 some years ago. So here I am. With that, I really want to turn it to Dave. And Dave, by the way, I have my video on just so you can see who I am, but shortly I'm going to turn it off just so I can save some bandwidth. And then I have my partner in crime here, Dave Watson. Dave, what can you tell me about yourself?
Well, good morning, everyone, and thank you for attending this morning's webinar. Thanks, Sy. Now, Sy's been with Southwire 17 years. I've been here 7 years, so he's up 10 years on me at this point. I've worked in multiple industries in the past. As he mentioned, I'm a principal engineer here at Southwire. Electrical engineer by degree, and I am focused on applications engineering, but also heavily focused in our codes and standards activities. So I am on 2 NEC code making panels, involved in a number of different organizations like the UL Standard Technical Panels, CSA, NEMA, multiple committees within NEMA, CANINA, and then trade organizations, et cetera. So a lot of our activities regarding, and especially for the building wiring cable market, which the products that we're talking about today, apart from the more industrial offerings, would be covered by the activities that I do. So again, thank you for joining, and I'm going to turn off my video now as well. And let's look at just a brief introduction to Southwire. Probably most of you already are well aware of us. We were born about 70 years ago. I believe it was 70th anniversary back in March, just before the pandemic really locked things down. So we've been here for a long time. We've made a number of acquisitions over the years. Again, I'm sure you're probably aware of these. We've made 2 or 3 more this year, as a matter of fact, but we are still headquartered in Carrollton. And that's where I am located. We're the world's largest privately owned producer of wire and cable. I believe that we're the largest, period, in the U.S. and 3rd largest wire and cable company in the world. So we've grown a lot over the years. We have, almost 8,000 employees, a bunch of plants, distribution centers scattered around the country, global in that we do sell product, I think predominantly to the Americas, but also in a few other places around the world. So our footprint is expanding. So we do have an international group to assist with those sales outside of the U.S. So we're going to get right into talking about the insulation and the way this kind of differentiates our single conductor products. So the insulation over the copper or aluminum bare conductor, we break it down into 2 basic types. And this is really based upon how they perform and how we manufacture those. So these are the thermoplastic and thermoset types of products. Now the thermoplastics, these are plastics that melt when they're heated above their threshold and then they harden when cooled. So PVC is the most common one that you'll encounter in wiring cable products. So these materials can be reheated and formed over and over again. Now, what does this mean? If you overstress the insulation, if you go above the maximum temperature on a thermoplastic type product, the insulation will deform and then potentially melt off of the conductor. With the thermoset, or cross-linked conductors, these are plastics that are going to become permanently hard and rigid when heated and cured. In other words, they're going to char and stay in place rather than deforming and melting off of the conductor. So they're not going to change shape after the reheat. Now, next slide.
Hold on, Dave. I'm trying to get it to go, but it's not. There we go. By the way, folks, I'm controlling the slide, so if there's a lag or something, it's not Dave. It's me. All right, go ahead, Dave.
All right, thank you, Sy. So this is a schematic of how we make the thermoplastic insulated products. So we have bare copper running off of a reel, going through an extrusion die. There's a hopper which is supplying the pelletized polymers that we use. And this is it's a combination of things that are put together to make up the insulation. We have to provide for a number of different characteristics in these products. So there are a number of additives that we put in. I mean, the color, that's an obvious one, right? You'll see the difference in colors, but then we also have to account for fire retardancy and mechanical strength properties, et cetera. So we have these combinations of materials that are put into the extrusion die, the insulation material and perhaps jacket material as well is extruded over the bare copper, and then it runs through a cooling trough. Now, this step is what's going to differentiate between the thermoplastic products and the thermoset products. So in the cooling trough, that's just simply a water, if you will, a water tray that the thing is, the product is pulled through to cool down, and then we wind it up on a take-up reel. So in the output of this product, there are no links established between the polymer chains. So these polymer chains are melted, extruded, formed over the bare copper, but then there's no further linking that's occurring between the polymer chains as it goes through the cooling trough. Next. Now, for the thermoset insulation schematic, it's a little bit different. We're still taking these materials and we're running them through an extrusion die. But now, after the extrusion die, this is running through a vulcanizing tube. So this is it's typically a heat is added and pressure is added at this stage. So it is a more expensive process to produce this, and the material has to cure as it's going through this manufacturing process. So therefore, it is a more costly product. But if you'll hit next, it should pop up with there we go. The beauty of this, though, is this vulcanizing process will now establish this linking between the polymer chains. And what does this do for us? It makes it into a more rugged insulation. So compared to the thermoplastic insulation, the PVC, this material, typically it's a cross-linked polyethylene, XLPE. This insulation is going to have better ability to withstand cuts, gouges, and things of that nature. So for the thermoplastic products, what we commonly do for our building wire products is we'll put a nylon jacket over that PVC insulation in order to protect it more. So we'll talk a little bit more about that as we progress through the presentation. So the single conductor product types that we'll look at today are the basic ones out there in the industry for use as a standard building wire conductor, recognized by the NEC, and these are, of course, used quite a bit in data centers. So we have the THHN, THWN-2 conductors. Those are thermoplastic conductors. XHHW-2 thermoset conductors. And then also the third one, the USE RHH-RHW, the triple rated product that is good for indoor-outdoor installations and can be installed direct burial. And that is also a thermoset product. So again, we'll go into each of these in a little bit more depth. The applications are the standard applications that you would think of: commercial, institutional, industrial buildings, things like data centers. Next. So let's go with the THHN, THWN conductors first. These are rated 600 volts. Now, you may have noticed on the last slide that we mentioned 1,000 volts. The thermoplastic products do not have a 1,000 volt rating. It's just 600 volts. You'll see when we go to the crosslink products that they, especially the XHHW, that is rated now at 1,000 volts. So that's something that occurred within the last 2 or 3 years. This product can be made with either copper or aluminum stranding. If it's copper, it is a compressed concentric stranding generally, or a combination unilase stranding. We may have a slide that talks about stranding. If not, this is, I think, a good point to mention that we have other presentations available. There's one that I do that's more focused on residential and commercial building wire products, whereas this one is a little more focused on data centers and covers a wider variety of products, and then some specific application notes, if you will, relating to data centers. These other presentations are more focused. For example, Sy does them on medium voltage products. I have one coming up next Tuesday that is focused just on the armored products, the metal clad products, and more specifically for residential and commercial applications. We have webinars that are focused on VFD products, webinars that are more of a utility type of focus as well. So please check out our other webinars that we'll be continuing to present as well through our Southwire Solutions University. So the aluminum products that are used for these type of conductors are going to be compact stranded. So they're going to take up less space. I have a smaller OD. There'll be less space in between each individual strand. So that's necessary for the aluminum conductors because the aluminum conductivity is less compared to copper. Therefore, you have to use a larger size aluminum conductor to be able to conduct the same amount of current without exceeding the maximum temperature capability of the insulation. Therefore, in order to try to mitigate that size difference, the aluminum product is made with compact stranding. So it's a little different from the copper there. Now on copper, it's available with stranded or solid stranding, if you will, for the small sizes, the branch circuit sizes, 14 to 10. Above that, you'll be looking at stranded only. So this is a PVC insulation with a nylon sheath. So the N in the product name stands for nylon. If you go back in time a few decades, the product was originally made just with thicker PVC and without the nylon. So that's the T. Typically, those were just THW conductors. We still make those today for products like submersible pump cable. But for the general purpose conductors, at least here in the U.S., I believe all the major manufacturers have switched over to this nylon jacketed type of construction. The nylon is there to protect the PVC insulation. So its job is really a protection of that. It's not to provide additional electrical capability. In fact, when we do the testing for the electrical parameters of this product, we do it without the nylon sheath. So even if the nylon sheath, let's say you're during the installation process, that nylon sheath or jacket gets damaged and the underlying PVC insulation is not damaged, what does this do to the product? Well, the nylon is there to protect it. So the nylon is very abrasion resistant. So when you're pulling it through conduit, it's good about protecting from any abrasion from the conduit walls. It can still be compromised, though, when it goes through conduit edges. Let's say that you have a burr where a piece of conduit was cut, and that's sticking up, and then it gouges through the insulation. So the nylon will give it some protection there, but it's not quite as rugged as, say, the crosslink product, the XHHW type of product. But the nylon sheath is there. Some people view it as sacrificial, meaning it's there to take the damage to protect that underlying PVC insulation. So if the PVC insulation is undamaged, then you still have all of the characteristics that you need, except for one little difference. The PVC insulation alone provides the electrical requirements. It also will be sunlight resistant for the size range that is sunlight resistant. It does provide a little bit extra gas and oil resistance compared to the PVC alone. But it's a small difference, but there is a little bit of an impact there. So the PVC insulation is the insulation. It's what's primarily there to protect the product and to provide the electrical and environmental protection that's necessary. So this product, the THHN type of product, is going to give you the smallest OD conductor, and it will be the lowest cost conductor for these general building wire type of installations. In conduit, sizes 1/0 and larger are CT rated, as we show, and so therefore they can be pulled as single conductors or plexed conductors within a cable tray. The W in the designation indicates that it's rated for wet locations. And so all of these conductors, the THHN conductors that we make are dual rated, are actually, some of the sizes carry more than the two ratings. But we're going to focus just on these two. So they're all going to be rated for dry and wet locations. So these conductors can be used outdoors, installed in conduit, and they cannot be direct buried, though. So they must be protected in some kind of a raceway. Next. The XHHW conductors, again, these are cross-linked thermoset conductors, also rated for wet locations. They're designed and NEC recognized to be used in the same applications as the THHN conductors. Excuse me. So why would you go with this product versus the THHN? The OD is going to be very similar in a number of sizes to the THHN. Some of them are going to be a little bit higher, a little larger. So yeah, the conduit fill will be a little bit higher when you use these conductors. But these conductors, as I alluded to earlier, are going to have that cross-linking in between the polymer chains. Therefore, they're going to be a bit more rugged, and so you should sustain less damage to your conductor insulation during the installation process. These products are rated for 1,000 volts now. This has been in place for, I think, about a year and a half, close to 2 years at this point. Aluminum is compact stranded again, so this is available in copper or aluminum, just like the THHN style conductors. 90 degrees C, wet or dry applications. Again, CT rated in sizes 1/0 and above. And next slide. Now, this is a triple rated product that is rated as an underground service entrance conductor, meaning it can be direct buried. And then it's also listed as, or Yeah, listed as a RHH, RHW style conductor. Now, where did that come from? That's a legacy wire type from back in the days where the conductors, I believe, were actually made with a form of rubber. Nowadays, it's cross-linked polyethylene is used to fulfill this requirement. So the RHH, RHW designations stayed in place, even though the products are no longer made with rubber. At this time, this product is rated 600 volts, maybe rated 1,000 volts a bit later, but it is made of the same type of material, meaning it's a cross-linked polyethylene, similar to the XHHW type of conductors. Now, the RHH and RHW-2 designations are recognized within the NEC for building wire use, meaning that this product, like the XHHW and THHN conductors, can be used indoors. And so I want to be sure and point out something here about this particular product. We make products that are listed as USE-2 only, without the RHH and RHW designations. Those products are part of what we would typically call UD or URD, so underground residential distribution. These may be the conductors that go to your home, as a matter of fact, if you have underground power service to your home. And the ones that are rated USE only are not allowed to be used inside of a building. They can only be used outdoors. They do not have the proper flame retardancy for indoor use. So this product, however, does have the necessary flame retardancy and the recognition by the NEC that it can be used internally within raceways, just like the XHHW or THHN conductors. And in addition, it can be used outdoors and direct buried as a USE underground service entrance product. So in terms of applications in comparing these products, you'll see a lot of similarities. I want to point out in the center, you'll see the low COF, which is low coefficient of friction, SimPull. The THHN and XHHW style conductors are manufactured with this SimPull technology. This makes them much easier to install in conduits, and you do not need to use a lube, a cable lube, when installing these products. Excuse me. The USC RHH RHW product, however, is not a SimPull product. So if you're going to be pulling that product through conduit, you will need to use a lubrication product for that. In terms of direct burial rating, you'll see that the THH and XHHW are not rated for direct burial, but the USE rating on the triple rated product allows it to be installed with direct burial. Now we can do paralleling and triplex, and we also have this flexible strand available for all of these constructions. Paralleling is where the product will arrive on one reel with all of the conductor colors that you need, all of your phase conductors. And so, for example, if you're running 3 500 kc mil conductors and you need brown, orange, yellow for a 480 volt installation, then those conductors will be on the same reel and you would pull them side by side together, but they are not twisted together or cabled together. They're simply in parallel with each other. Triplex is when at the factory, we actually cable or plex those conductors together. They're twisted together. So you've probably maybe familiar with triplex and quadruplex products that are for service drop, are for underground service entrance. Also, if you look at the conductors inside of an MC cable, are a tray cable type of construction. Generally, those conductors are going to be twisted or plexed together. So we can do that with these larger size products. And indeed, for some of data center installations, this is specified by the owner. Next. So a bit more about the Sim-Pull jacket. So this allows you to install the conduit, install it in conduit without using the pulling lube. In order to really get a good feel for this without pulling the product, you can take a look at our cable pull calculator, which is available on our website. This cable pull calculator is available in mobile and Excel versions. I predominantly use the Excel version, and in that spreadsheet, you can specify what the coefficient of friction is for the conductors that you're pulling. Now, we have it preloaded with our Southwire products, and so you can see the fairly obvious effect of this low coefficient of friction when you pull this product. And it also will allow you to pull through more bends without exceeding the pulling tension or sidewall pressure. Just very quickly about that. The NEC does have a requirement of 360 degrees of bends that you would need to install a pull box. And you still need to comply with the NEC in regards to that. But the use of Sim-Pull products in many, many instances would allow you to do a straight pull through at that box rather than having to pull the conductors out and then pull them back in again. That limitation was put into place years ago, primarily because of the friction that occur when you try to exceed more than 4 90-degree bends. And nowadays, with this low coefficient of friction Sim-Pull product, we can typically pull these through many more bends, but still need to comply with the code. But this, again, it allows you to put in a straight through pull box rather than having to actually pull it out and pull it back in. So it saves you labor and may save you some expense on the pull box as well. So this is going to help make the product much quicker and be able to install it at a lower cost. Now, paralleling versus triplexing. So on the paralleling product, you can see down at the bottom, so delivered on one reel, it's going to pull as one cable. Now, the bending radius on this product is going to be based upon just the single conductor bend radius. So you actually end up with a smaller bend radius in total. And this can be installed with maintained spacing on cable tray installations. What do I mean by that? Maintained spacing is where you keep the conductors separated from each other so that there's no mutual heating or very limited mutual heating of each other. And the NEC 392 article on cable trays will allow you, depending on the type of cable tray that you have, it will allow you to use a higher ampacity or higher current carrying capability for these conductors if you can keep them spaced out, separated from each other. So that's the maintain spacing. So with paralleling, if you want to have the conductors spaced out to try to allow for a higher ampacity, this is the way to do that, where it's delivered on one reel. Now, up at the top, we have triplexing. Triplexing is also going to be delivered on one reel. It's going to pull as one cable, but now these conductors are all twisted together. And there are some possible electrical reasons, I'm not getting into that in today's presentation, of why you would want to plex those conductors together. But what you will end up with is now the bend radius is going to be based upon the total OD of the assembly, because when you bend this, you're bending 3 large conductors in an assembly. So you're going to have definitely a larger bend radius that you'll have to take into account during the installation process. It will consume less tray width because now the conductors are plexed and up higher from the taking up more space vertically from the cable tray. Now, this is going to be a lot harder to handle and work with. So unfortunately, it's going to be easier to damage this because of the stiffness of the copper conductors, and especially now once you plex it together, it does make it very difficult to work with. So it's going to be easier to damage during the installation and handling of this product as compared to paralleling or pulling individuals. earlier alluded to the fact that we have flexible versions of the THHN and XHHW, and I believe also we said the RHW USE product as well. So these flexible conductors are a high strand count, class I conductors. So they're made with a different type of stranding, like a rope lay stranding or something, with much smaller strands. This is going to make a product that's easier to bend. Now, the recommended minimum bending radius for the final installation, it's still going to be the same as the standard stranding classes for these products, which are going to be the Class B and Class C strandings. So these are made with fewer number of strands, larger strands. So you're still going to have that same minimum bending radius. However, what this is going to do to you, though, is when you are terminating the product and you need to train or kind of pre-bend these conductors, and you need to have more room, or let's say you have limited room in the panels or the gear that you're installing this at. And so you need to have this extra flexibility so you can get the product installed. Then this is going to provide that for you. So handy product. We're seeing a lot of people utilize it for that specific requirement. Next. I see that I'm getting into size time, so I'll hurry. These products are available with pulling heads from the factory. So rather than having to make up a pulling head at the job site for all the conductors, these pulling heads are applied to each conductor, and they are sealed to prevent any moisture from getting in, which is pretty important when you're pulling underground through conduit that probably is filled with water. So these sealed factory installed heads are going to keep the installers from using knives. It makes it a lot faster because they can just take these, attach them to a clevis, and start the pull. And so it's going to save on labor, should reduce potential injuries, and keep the product properly sealed as it's installed. So next. Just a couple of slides on MC cable. Again, the more detailed presentation will be coming next week. But MC cable does get utilized in data center applications. This is where you have pre-installed conductors, meaning that you have conductors that are factory installed inside of a flexible sheath or armor. So this is going to be like a flexible metal conduit, but when you receive the product, it's all as one cable. And this is, I think, especially popular for the smaller size conductors for the branch circuits in data centers. So they provide quite a bit of labor savings compared to the pipe and wire type of installation where you're pulling individual conductors through a piece of conduit. Next. So we have a lot of different kinds of these. You can get them PVC jacketed, which would make the product usable in wet locations. We have healthcare facility rated products, neutral per phase products as well. And you can see just multiples. One I'll point out, the MCPCS. This is a product that is designed with power and control conductors within the same cable. Most often used for LED lighting applications where you have a 0 to 10 volt dimming circuit, but can be used for other control applications as well. So we make these PCS type constructions for standard MC cable, for a healthcare facility MC cable. We also have variations for fire alarm applications. For riser, the riser MC is a great product for, let's say you're putting in a high rise, and if you were installing standard MC cable, or if you were installing pipe and wire type of installations, single conductors and conduit, there is an NEC limitation on the vertical height that you can install those without putting in some kind of conductor support to ensure that the conductors do not fall out of the conduit or fall through the armor on an MC cable. Riser MC is constructed such that that conductor support is continuous all the way through the cable. Therefore, you do not have to install the special conduit supports at the prescribed distances vertically. So the chocks that you might have to install for the conductor supports in a junction box are the extra 90s that you would have to install to relieve that weight, that pressure on the conductors. You wouldn't have to do that with the riser MC cable. So you would see a labor and cost savings in the installation of the product. Next. Just some more examples of the types of the feeder products we have. It's both aluminum and copper products. And again, popular for high-rise type of buildings, hotels, condominiums, stadiums. We do see riser MC, standard MC products used quite often in stadium type installations as well. Next. And there we go. Now I can hand this off to Sy. Sorry that it went over.
That's okay.
But it's yours now.
You're good. Can you hear me, Dave? Just check on the.
Yes, sir.
Okay, great. Thanks, Dave. Appreciate it. We're going to step up the voltage a little bit for 600 volt, 600 and medium voltage. Again, this is really, it's a hodgepodge of what with my experience in the data centers. I've been to a lot of data centers, and what is it that I've seen and what I have experienced. And so this is really, like I said, there's no continuity to it. It's some things that I've experienced, and I thought, well, you know what, for the audience, for our listeners, this would be good. So, in industrial cables, as you might imagine, they're more robust and they can take more field abuse than the products that Dave talked about. Not to say that those products aren't good. It's just that, just like I said, these products, while the inners are no different than what Dave talked about, inners are XHHW, for instance, but it has an overall PVC jacket. You can see this is a tray cable, whereas it can take a little bit more ruggedness. This looks like an MC cable, but it has a jacket. Again, it's control, and we can put power. Again, it can take more ruggedness. This would equate to, for instance, you got THHN. Well, this would take the place for THHN. My goodness, it has an insulation and then a jacket. This is the most rugged one out there. It's still rated 600 volt, and then we finally have the tray cable multi-conductor control with an overall jacket. So the point here is, if you want ruggedness, then you would have to go to the industrial type cables. Whereas, whereas if you want a little bit more economical and something that, you feel like you want to save money, obviously you would use some of Dave's products. So let's step it up to the medium voltage. Again, this is a hodgepodge of stuff that I, saw as I go to these different job sites. The shielding, which is kind of stumps people, engineers and end users. Well, which shield should I use? Well, the most common shield is a tape shield. And this is, I have a picture of it right here. There's other shields, what we call a concentric neutral. This is used predominantly in the utility market, whereas this is a hybrid of concentric neutral plus a tape shield. This is a corrugated tape shield. It's just like this, but a corrugation. But let's concentrate on two of them, this one and this one, just so you can understand the difference. The tape shield, again, which is an industrial type of cable used predominantly in the industrial and in the data centers. That's used predominantly in the data centers. Not to say this isn't used in the data centers. We'll get to it in a minute on its applicability. The tape shield, this is usually used in a three-phase application. For instance, you're going from the switch house from the switch house, which is outside your data center. You take the power up to your switch gear. Now you're inside the protective area. You're inside where you have to go into a turnstile where you're into the data center. So now you can use this tape shield, whereas the tape shield here is there to bleed off the electrostatic charge. It cannot handle neutral currents, but again, you're going from the switch yard to a let's say your big transformer, 25 MVA or what have you. And because it's dedicated to that transformer, normally there's balanced phase, but balanced current between the phases, and therefore you really don't need a neutral return. While if you do want to protect your equipment and so forth, you can run a separate 600 volt like THHN, green THHN, or XHHW along with the conduit. So this is a tape shield. It's really a 5 mil tape shield. It's pretty skimpy. It can't handle that much current. But again, understanding that the reason for that is that it really is not there to carry neutral return rather than just to bleed off the electrostatic charge. Now this one has really, it looks like one conductor, but in reality it's two conductors, because this is the phase conductor and this is the neutral, and hence the word concentric neutral. This one, yes, this one is designed so it can handle neutral returns, and that's usually mostly used in utilities. Whereas utilities that there's a lot of, imbalances between the phases, phase A, B, and C, because each phase is feeding a different subdivision. And once you get into a subdivision, you got so much diversity in loads and diversity in use of loads, whereas that phase A might carry more current than phase B or C, because not everybody's turning on their air conditioning at the same time, or the welders, or their power equipment, or the coffee makers, or the TVs, or the hair dryers. Not everybody's turning. So that's why a concentric neutral is used to return that current. We have seen it in the data space. However, this is more predominates in the data space market. This is UL listed. We can make this UL listed, but this is, as I said, it's mostly used for the utility. The other two tape shields, I really honestly wouldn't worry about it, because they're very, very, very niche-y and not very much used. There's different jackets. We see most of the jackets in the data center world, and we're talking about this part of the cable construction. And mostly it's used PVC polyvinyl chloride. It's one of the more economical. It's pretty good, but it's loaded with chlorine. Hence, you can hear the word chlorine, polyvinyl chloride. And if there's a fire and this chlorine if the cable catches on fire, it releases chlorine gas, and when a chlorine gas mixes with any humidity or water, it turns into hydrochloric acid, which when it lands on any equipment, it will corrode it. CPE, some companies go with CPE, chlorinated polyethylene, while it still has chlorine, but it doesn't have as much chlorine as the PVC. So I'm kind of really looking at this column. These columns right here, they're all good in fire retardancy. That's because, remember Dave talked about the polymers when we put them into the hopper. Well, we dope them with different products or additives to make it, whether it's the coloring, to make it more fire retardant, to make it, process better, and so forth. So one of the products we put in is fire retardancy in it. So they're all really good. LLDP, low density polyethylene, is really, it burns like a candle. So obviously you don't want that. Temperature range right here. in oil and chemical, they're fairly good. PVC doesn't fare too well in oils and chemical flexibility. They're all not too bad. Too bad as far as cold temperature PVC polyvinyl chloride. It's not the best, but obviously these are better. But let's go back to this chlorine column. So if you are in an environment, and really this is probably for you, for those of you engineers out there, and something you can look at a low smoke, zero halogen. If you have BNV is on here, Jacobs is on here, and for those of you engineers that are working with data centers, and they want, in fire obviously is one of the things that they're really concerned about, because obviously they want the best reliability. You may want to think about a solenoid. Well, what is that? That's a low smoke, zero halogen cable. In other words, it has no chlorine whatsoever. It burns clean, and that's what we use for people movers, and that's where the subways, any transit authorities, they use these types of jackets, so it burns clean. It doesn't give off any toxic gas. So in case of a fire, it gives the populace, or the people, a chance to escape out of the subway and outdoors. So if you're really thinking about that, if this comes up, a subject that comes up, you really want to think about it. It is a little bit more expensive. Sorry about that. It is a little bit more expensive, but not that much. But for what it brings in, I tell you, in my experience with data centers, I mean, if you ever design anything for data centers, you can see how really careful they're. Very concerned about fires. I mean, they have firewalls. They have obviously big diesel engines to fire up their fire pumps and so forth. So that's really concerning. So just food for thought. A lot of times I'm asked as an engineer, well, when we terminate the cable, the medium voltage, should we terminate it at both ends or not? Should we ground it at both ends or not? Here's a cable. Imagine this end, imagine this end is at the switch house. This end is inside the inside of the data center area. Again, you have to go through the turnstile to get in there. This is outside where on the switch yard where the utility feeds it. Well, should I, ground it at both ends? I have a termination here. I have a termination. Well, when you look at a cable, while it looks, very simple in construction, from an electrical standpoint, it's really amazing what of the different things that go on within a cable. Well, if you really look at it, so I have this energized at 60 hertz. It's carrying, a lot of current. I have this tape shield on it. Really what it's acting as is really a transformer with a 1-to-1 ratio, because I have current coming in here. It's inducing a flux onto this tape shield, and really it opens up. It becomes a transformer, just like I show it here. So on this side, if you do open it, you're going to have an open voltage right here, which is, that's not the end of all. That's fine. And you can calculate the open voltage. There's methods of calculating what this open voltage, obviously the longer the cable, the more, the higher the open voltage. And obviously it depends on the current too. The higher the current, then the higher this number is. Again, it's not the end of the world that you can do that. There's absolutely nothing wrong with that. But then if you want to ground them at both ends, again, the same scenario, but now I've grounded at both ends. Again, you still have that transformer effect, though now you have what you call circulating currents. Yeah, this is at ground potential. I get it, but you still have circulating currents. And because this tape shield has, inherently has a resistance, you got the I²R going in there, and that heats up the cable. When you heat up the cable, that means you got less ampacity. But want to, I want to make this clear that the NEC, the National Electric Code, when you go by the National Electric Code, they're assuming this. They're taking the worst case scenario. So the ampacities that you get from our tables or from the NEC, it's looking at this as the worst case scenario. In other words, it's looking at circulating currents as well. So that really is the difference. The other one, you get more ampacity. So in other words, if you really want to get more ampacity out of it, you might want to open up the shields. But if you ampacity is not an issue, it's oversized, then you can ground them at both ends. All right, so real quick here, really a little terminology that you may want to know about a reel. This is the inside is called the drum. The flange is this is called the flange. This middle hole is called the arbor hole. This is the terminology from NEMA WC26. The minimum drum is based on NEMA. So we size this drum based on NEMA WC26. The minimum installation bend radius is based on NEC, ICA. It's almost twice as much. A lot of times I get, hey, Sy, you sent me a cable that the drum diameter is, X. Meanwhile, you violated the bending radius of this cable because you put it on a bend radius that is less than what the NEC or ICA asked for, which is almost twice as much. Well, again, the reason is because when you're on a reel, we go by NEMA WC26, and you're not really under tension, you're not pulling it, so forth. So the minimum bending radius on a reel is always going to be smaller than what we ask you for in the field, which is normally the OD. If it's shielded, normally the OD times the 12 times 12, which is your minimum bending radius. The point I'm making here is don't be misled that just because I sent it on a drum diameter that is smaller than what is allowed in the field as far as minimum bending radius, that's because of this. We go by NEMA, whether it's myself or our competitors, we all go by NEMA. NEMA tells us what size drum diameter you should use. When you get the reels, we always want you to be careful, always inspect the reels when it's delivered. If it's on reel wrap is torn, be careful. Make sure there's normally a wrapper on it. If there's a wrap, make sure you look at that cable before you take it off the truck and say, "Whoa, wait a second! The wrap is gouged, and I see the insulation or the jacket is gouged." Let us know. Unloading the equipment should not come in contact with the cable or its protective. This is how you want to unload it. Again, through my experience at the data centers, and for that matter, any job site, this is really how you want to unload it. And then if you have these really heavy reels that are coming on a flatbed and you want to pick them up with a fork, with a crane, make sure you unload them get the right spreader, the correct spreader width, so you can unload these off the truck. So we really recommend that you put the reels, a consideration should be taken to use steel reels if the cable weighs more than 1,000 pounds. So if the reel weighs with the cable more than 1,000 pounds, you really want to look at steel reels. Always have the reels on a hard surface. Cable ends must be sealed to prevent the entrance of moisture. Obviously, that's you want to protect that cable. You don't want water get into it, so you want to cap it. And if it's on wooden reel, you really want to inspect the wooden reel before you use the cable. So again, if you're in for indoor storage, we recommend these 3 bullets. If it's a lot more than 1,000 pounds, you really want to ask for a steel reel. Seal them, and then if you after 6 months later you want to take it out, just make sure you inspect both the reel and the cable. Now, the thing about steel reels, I have to tell you that the reason why it's not this popular is because you're going to have to pay a deposit on it. We take a deposit, and when you ship us back the reel, obviously you get it back. So that's the sticky thing about steel reels, but obviously there is a really good reason for steel reels. If you go outside, store them in outdoors, this is not what you want to do. You really want to store it on a gravel that's been tamped, that is a little hard, whereas the reels don't sink, because if the flanges sink, you're going to be resting on the cable. Obviously, you don't want this kind of behavior. Again, you should use steel reels if it's more than 11,000 pounds. Make sure you seal the ends and visually inspect the wooden reel. And if you do use a wooden reel, make sure you look at it before you take it out, and make sure that both the reel and the cable are in good condition. Because frankly, the cable might be in good condition, but if the reel is bad, well, you can't really unreel it. So I got 2 more slides. I know I'm running out. I'm going to stop right here. I'm going to talk about this guy. Let's see. Yeah, we'll talk about this guy and stop. So I again, through my experience, this is almost every job site uses. And while it's a very good piece of equipment, I'm not here to say it's bad or anything, but it has its quirkiness. This is what's called a bed roller. You put the reel on here, and these shafts turn, and as they turn the reel, and you can you can feed the reel that way. The problem with this, when you use really heavy reels, I mean wooden reels, the problem with wooden reels on this, first of all, wooden reels are not meant to take this much abuse, because you got this reel is turning, maybe 50, 80, 150 turns. This wooden reel is not meant to be turned that much on its flange. And the heavier the cable, the more it wobbles, and the more issues you'll have, because then the like I said, the flange is not really is made to take that abuse. Whereas if you have a steel reel, these really work very well with steel reels. So that's really, especially on heavy reels. This is good on heavy reels. You really want to use steel reels for anything above 8,000 pounds. If it's less than 8,000 pounds, yeah, you can use it on wooden reels. But once you get up to 8,000 pounds, you really want to use steel reels. So with that, really, I'm going to stop. And Beth, if you have any questions that came in, or just open it up, really. I know we're running out of time. Just open it up, let people talk, and if they have questions, Dave or I will answer them.
Yeah, thanks, Sy. I don't see any questions, but I would like for you guys, if you can hang on here. It's already 12 o'clock, but if you can hang on for a few minutes and you want to ask a question to Sy or Dave, you can raise your hand and I'll unmute you and you can talk with them. If you're not sure how to do that, if you're on a PC, if you'll click on the participant little button, the person icon, and look underneath your name, and there will be a little hand you can raise. And then if you're on a notebook or your phone, you'll have to click the little ellipsis. Click the ellipsis, and that'll allow you to raise your hand. And then I can look at the attendee list and see who's raised their hand. And you guys, I'll unmute you if you want to talk to Sy. Thanks for the comments there, saying great job. Always a pleasure to hear from you, and thanks for the information. I look forward to the MC cable presentation. So thank you, Jones, for that.
Mm-hmm. By the way, this if you want this presentation, it will be just let Beth know, and yeah. she has a copy and she can send it to you. This is if you want it. Again, I know a few of you guys on here, so don't be shy to ask questions.
I put my email into the chat, so if you want to just email me, I'll definitely send you a copy of the presentation, a recording. I can send you a link to it. And then just to let you guys know, while you're thinking about raising your hand, there have been some issues with people saying that they had trouble registering for new, say you've already got your name in the system, but you want to register for a new class. Well, there is a little procedure. You have to modify your registration, and this is meant to simplify things so you don't have to register over and over. If you follow my directions, you won't have to enter any personal information. So in your chat window, if you look up, I put, if you have trouble registering for new classes, here's a resource for you. That's a Dropbox PDF. It just gives you instructions on how to register for a new class. So I thought I'd put that out there if anybody's having any issues. All right, guys. I don't see any hands raised. You did a good job, Sy. And Dave. Dave, you did a good job.
All right, that's great.
Thanks. Let me just say real quickly that if you have any technical questions relating to the presentation today or otherwise in regards to Southwire products, you can reach the applications engineering team at Cable Tech Support. That's all together, one word, Cable Tech Support at southwire.com, and we'll be glad to help you.
Yep, and I put that in the chat window as well. Cable Tech Support at southwire.com.
Thank you.
All right. And yeah, I was just going to say one quick one. I am giving a presentation on medium voltage cable. If you're really involved, would like to hear about that. That is on Tuesday, this coming Tuesday, medium voltage technology application fundamentals. So with that, I will let you guys go. Thanks. I know we went a little bit over, but you guys have been a great audience. Please stay safe. And from Cleveland, we'll sign off.
And from Carrollton, we'll sign off. Bye-bye.
Yes, goodbye, everybody.
Take care. Lovely.